This is a quick revision video on linear simultaneous equations where no changes have to be made. This is on both Foundation and Higher. Here we have three different questions. Let's start off by looking at question number 1. We have two equations and two unknowns. If we've got two unknowns, which in this case are the x's and the y's, we need two equations to solve. We don't just go ahead and try numbers or guess numbers for x's and y's. If we look here, we would say that this is equation number 1 and this is equation number 2. Here are the rules. What we need to do is ensure that either the number, which we call the coefficient, is the same for the x terms or the same for the y terms. We can see that in the first equation we've got 3x, and in the second equation we've got 1x. 3x and 1x are not the same. What we can see here is that we've got the 2y and the 2y. So we know that the y's are the same. As soon as I have one of these the same, either the x's or the y's, we consider the sign in front of that term. If they are the same, we subtract. If they are different, we add. So in this case, they are the same, so we are going to subtract. When I say subtract, all we're going to do is equation number 1 subtract equation number 2, or if you like, subtract downwards. That will eliminate the y's for us because they are the same. So subtracting down, we've got 3x minus 1x, which is going to give us 2x. We've got 2y, subtract 2y, which gives us 0. And we've got 22 minus 14, which is going to give me 8. So I've eliminated the y's by subtracting equation 2 from equation 1. This leaves me now one unknown to solve. If 2x is equal to 8, dividing both sides of the equation by 2, 1x is equal to 4. So we've solved for the x. All we need to do now is simply substitute this value back into either one of the equations to solve for y. So all I'm going to do is substitute x is equal to 4 into equation number 2. You can, of course, substitute it into equation number 1. It's just slightly easier in this case because we've only got 1x. So for equation 2, we now have 4 plus 2y is equal to 14. We're now going to solve this simple equation for y, subtracting 4 from both sides. We've got 2y is going to be equal to 10. So y is going to be equal to 5. So the solutions to our simultaneous equations are x is equal to 4 and y is equal to 5. If you want to check that it works for both, please go ahead and do so, as that's a check-in mechanism. If you're unsure whether they're correct or not, just check that they work for each equation. So if we look at equation number 1, 3 lots of 4 gives me 12, 2 lots of 5 gives me 10, 12 plus 10 gives me the 22. So that works for that one as well. Okay, let's look at this one. This is question number 2. We've got 5x plus 3y is equal to 13. 4x minus 3y is equal to 5. So the first thing we need to do is establish whether the x's are the same or the y's are the same. In this particular case, we can see now that the y's are the same. 5x and 4x are not the same, but 3y and 3y are the same. So all I'm going to do is write here that the y's are the same. So I'm just going to write that y is the same. This is equation number 1. This is equation number 2. We now look at the sign in front of those y's and we can see this time they are different. So if the sign in front of the number that's the same are different, so I'm just going to write that, they are different, that means what we need to do is add the two equations. So this time I'm going to add the two equations together and that will eliminate the y. So 5x plus 4x is going to give me 9x. If we add these two just here, we've got 3y plus negative 3y just gives us 0. We've got 13 plus 5 and that gives me 18. So I've eliminated the y's and that leaves me a simple linear equation. 9x is equal to 18, so x is equal to 2. At this stage, we substitute that into either equation. I'm entirely fine with whichever one you do. I think it's going to be easier to substitute into this one. So if I substitute that now into equation number 1, the reason I'm doing that is to avoid the negatives. So we're going to have on the following, we've got 5 lots of x, which gives me 10, plus 3y is equal to 13. Subtracting 10 from both sides of the equation, 3y is equal to 3, and y is equal to 1. So we've got x is 2, and we've got y is equal to 1. Let's just check that works here. 4 lots of 2 is 8, minus 3 lots of 1 is 5. That works. So let's move on to the next one. This one just here, we've got 6x plus 5y is 28. 6x minus y is equal to 16. The reason I've included a third one is that this time we can see that the x's are the same. What I want you to think about now is with equation number 1 and equation number 2, we don't have a sign in front of that 6x, but we should hopefully know that if we don't have a sign, both of these are positive. So we can see now from here that the x's are the same. You certainly don't have to write this out each time where I'm writing that the x's are the same and that the signs are the same, but to begin with, it might help you out. So we've got same, which means that we need to subtract. This is a slightly more challenging example, so do be careful. So if we do equation number 1 minus equation number 2, 6x subtract 6x is 0. 5y subtract negative 1y, remember this is just a 1y, gives us 6y. When you subtract a negative, it is the same as adding it. So we get 6y is equal to 28 minus 16, which gives us 12. We can see this time we've got y is equal to 2. I've eliminated the x's this time. So all we need to do now is simply substitute into either one of these equations to solve for x. I'm going to substitute into equation number 1. The reason I'm choosing equation number 1 is because, again, it's positive rather than negative. If you're comfortable using the negatives, go ahead and do it. So what we've got then is 6x, so 6x plus 5y, or 5 lots of 2 is going to give us 10. That gives us 28. We've got 6x is equal to 18 by subtracting 10 from both sides of the equation, and x is equal to 3. Let's just check that works in the second equation. Well, 6 lots of x, 6 lots of 3 is going to give me 18, minus y, which is 2, and that gives me 16. So the solutions are x is equal to 3 and y is equal to 2. Common error here is that students do not solve for both. They solve for one. Like on the first one, they solve for x. On the second one, they solve for x. On the third one, they solve for y. But they don't actually go ahead and find the second unknown. You must do that and check that they work. So if you're not comfortable with that full-length tutorial on my website, this is brief revision. So as ever, what I'm going to do is set you 3 of these. You're going to have a go at them and try and find the answer for both x and y. Just to give you a bit of a heads up, this one of the answers is going to be, let's not scribble all over it, one of the answers is going to be a negative number. So do be careful, use the same technique, hit pause, have a go, then I'll do the answers. Okay, let's do the first one. So we can see now that we've got 7x plus 2y is 15, x plus 2y is equal to 9. We've got the y's the same, so we're going to eliminate the y. The sign in front of them is the same, so we simply need to subtract. So what we're going to have is 7x minus 1x, which is going to give us 6x. We're going to have 15 minus 9, and that is going to give us 6. So 6x is equal to 6, and 1x is equal to 1, or x is equal to 1. Substituting that in, I'm going to substitute it into equation number 2 because it's a lot easier. So we get 1 plus 2y is equal to 9. That gives me now that 2y is equal to 8 by subtracting 1 from both sides, and then y is equal to 4. So the answers you should have got are x is equal to 1 and y is equal to 4. As you can see, I've gone through that a lot quicker because this is the technique that I would use once I'm comfortable with it. Okay, let's look at question number 2. We've got 4x plus 1y is equal to 23. 6x minus 1y is equal to 37. We can see that the y's are the same, or coefficient, the number in front of them is both 1. So what we're going to do now is consider the sign in front of them. we can see that they're different, so we need to add them. Adding them will eliminate them, so adding equation number 1 to equation number 2, 4x plus 6x is going to give me 10x. If we add y and negative y, that's going to give us 0. Adding these two is going to give us a total of 60. 10x is equal to 60, 1x is equal to 6. What I'm going to do now is substitute this into one of the equations. Doesn't matter which one, you might do a different one to I have, but I'm going to do the first one. So 6 times by 4 is 24, so 24 plus y is equal to 23. Subtracting 24 from both sides, we've got y is equal to negative 1. So x is equal to 6, y is equal to negative 1. Let's just get that. 6 times 6 is 36. Subtract negative 1. Subtracting a negative means you're adding it, and that gives you 37. So answers, x is 6 and y is equal to negative 1. Finally, let's look at this one just here. We've got plus 3x plus 5y is equal to 28 and negative 3x or minus 3x plus 2y is equal to 7. We can see now that the x's are the same, but the signs are different. We've got a plus and we've got a minus. So what we're going to do is add these two equations together. Plus 3x minus 3x will give us 0. 5y plus the 2y gives us 7y. 28 plus the 7 gives us 35. 7y is 35. Dividing both sides of the equation by 7, y is equal to 5. Substituting that back in, again I'm going to use the easier one to avoid the negatives. Going into equation 1, we've got 15 plus 5y. So all I'm doing is simply substituting that into the equation. 15 plus 5y is, sorry, let's put that in correctly. I've put that in the wrong one. My apologies. 3x, let's write that there. 3x plus the 25, I substituted that in for x instead of y. 28. 3x is equal to 3 and x is equal to 1. Again, if I continued with that, I would have seen that it was wrong and it wouldn't work for both of the equations. So if we just go ahead and substitute that into the second one, negative 3, so negative 3 times 1 plus 2 lots of 5, that does give us 7, so it's correct. So there we are, quick revision on linear simultaneous equations where no changes have to be made. In another video we will look where we have to either change the x's or change the y's.